So I made some parts, so I'm quite pleased with the way these have turned out. A point to mention, when 3D printing, it's done in layers. So if it's on the deck that way, as it prints the layers, it's boom, 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 boom. But of course, when you've got a shaft like that, because it's layers upon layers upon layers, it's almost like a grain in there, and that it's actually, it could be brittle. Out of all the filaments that I've been using, this is Sunlu. This is standard PLA, but this is Sunlu PLA 3D printer filament, 1.75mm, blah 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 blah. This is an amazing filament. I'll tell you for why. I've used lots of different filaments, and I find some of them can be quite brittle, especially like that is printed. That will eventually snap, but that took a massive amount of force to snap that off. But as you can see, with a heavy landing, that could happen. So that was going to sit on there, which means then that would fall off. I've got square section carbon fibre that I wanted to use for the motor mount. So I've made quite a substantial motor mount. And then I suddenly thought, I've got no thrust angle. Do I want to put washers on there and give it a bit? When you put a motor on, if you put it on a flat plate and it's perfectly flat in line with the fuselage, then every time you accelerate, the plane will go up. To compensate for it, the motor will be pitched down slightly to the right, and that is what they call the thrust angle. Now, obviously when you're making your own plane, you must allow for it. I've looked at some of the other models I've got. The slow flyers tend to be a little bit straighter. The things that fly fast, more radical. So what I've done, like I said, I've come up with the plan that I'm going to have a tri-section, and the battery then can sit inside that section. So the motor, as you can see, pitching slightly down and pitching slightly to the right. Now I've designed some wedges so that if I need to change that, I can put them, but I can shim it out with washers. So, and I've used a motor cage to give me a little bit of protection, so the motor's protected, so if it goes in, nose in, at least the motor should survive, rather than it being on there and snapping off. So I've gone with that design, but I'm quite pleased that motor mount is perfect. To support the motor mount, I've printed some of these as well then, which can actually slide on, so it makes a cage. So how am I going to attach this to the pole? So my original thoughts was I'd do that and then I'll bolt through, but then I thought I'm creating natural weak points. I've got carbon fibre, but then by drilling holes in it, I give it areas where I could snap it off. So I came up with an alternative mount. So as you can see, I've got the centre there for the carbon rod and the two square sections. So I can put this on and that keeps them in position. Nice tight fit. And then I needed wing support, so I developed this. So this is really, really strong. But again, same layout. And this will support the wing. And to make this work, because these wings are these metal buckles, I've cut like what looks like a keyhole. So the buckles will fit through the keyholes as part of the wing. And then I can put a band there, so if I did take an impact, the elastic bands would stretch and pop off. But that would keep it perpendicular to the motor mount. And as an additional wing support, so when the wings go on and that's fixed, it gives it an extra support on there, so you know, it just stops a bit of the movement. And like I said, another set of grub screws in there will keep that locked on, and this will be helpful for other wings. So if I decide I want to try maybe the Easy Star wings, and I put the carbon fibre dowel through there to keep it in place, but I can it'll support then whatever wing set I use. So that gives me the wing support, and then the carbon fibre tube can pass through there and through there, and that is not going anywhere. That's solid on there. And I've drilled not drilled, I printed little holes, little 1.2mm holes, so I could put a grub screw in there. So the grub screw can clamp onto the carbon fibre rod. I had some carbon fibre undercarriage. So I printed that section. I put the undercarriage on first, because I printed it with the hole for the rod. But it's cap-ended, so it only goes in halfway. So it'll be a nice finishing piece. But I've got a hole then that will allow the cables to come through to go to the tail controls. So I got a nice, perfect position then for the battery. So I've sized it for a 2200 battery, a 3S or maybe a 4S, so there's plenty of room. So then I thought, well, rather than strapping the battery directly on there, I'll make a battery tray. So I printed a battery tray. And then I thought, I got a lot of carbon fibre. Where am I going to put the receiver? I don't really want to put the receiver on the carbon fibre. So I decided I'd follow the same design, but I'd like to put a little shelf there. So that can go on there. And give me a little tray for the receiver. Got little holes on the back for the antenna wires then to drop down and hang up on the lower end. And the carbon fibre tube, as I said, goes through. For the tail section, I designed this, and that was based on these fixing points. So I've retained the little mount at the bottom because I'm going to use that. That stops the tubes from splitting as the screws go in. The bottom was shaped so it's quite level, so it was perfect. And in case you was wondering, this is a tail section off an old Phoenix 2000 glider. With that slotted on the tube, everything was quite level and quite true. And there's a hole in the bottom already pre-cut. I don't know whether you can see it there. So I can bring the cables out. So I've made some extra long cables. So I made a little servo caddy that can slide onto the tube. I've cut a V section in the tube because there was a V section actually. I designed a V section in there so that when it's on it can't rotate, so when it's fixed in that position that tail is solid. And then I can line up the tube with the wings, so line up the tail section and pin it, and that's going to be solid. And then I'll pin that with little grub screws so that it is in the position where I need it to be. That is a lot deeper than I thought. So I simply 3D printed a skid. Job done. So I'm not going to glue for the tail section. I've used these little tabs, so I can drill a small hole. I'll put a rod through there, carbon fibre rod, and then I'll tape it. So the tape will keep the rod there, and the rod then will stop it coming off. And if I want to remove it, on the tail section there's little tabs. And these little tabs then I use for doing the fixings. So I'm quite pleased with that. There was a lot of thought went into this, because I didn't want to weaken the carbon fibre boom. I wanted it so that it could take a bit of a knock, and with me flying it. I wanted it solid, because that ain't moving. It can't move sideways. There's no twist. And there's another added bonus. The biggest factor is the centre of gravity. So I can move that forward and bring the undercarriage forward to make sure I get this in the right position, so I can adjust it to give me the centre of gravity I want, because different wing sets. So I can slide this, so we can make the plane physically shorter or make it physically longer. I can start off with it as long as it can be, but by having the servos, I can use that to fine-tune the centre of gravity. So when I've finished assembling the plane and I've got the wings on, I've got everything in position, I can then check the centre of gravity with the servos installed and make sure that the plane is all balanced out with a battery in position. And obviously I got a position of the battery can slide back and forward as well. but at least I can get the centre of gravity without having to add weight. And this plane is going to be pretty light at the end of it, maybe a bit heavier than if it was just a foam plane, but how cool is that? And carbon fibre and black 3D printed parts. That's, in the words of Captain Bosch, it's sexy plane, ooh, sexy plane. Ooh. Okay, Captain Bosch. So if you haven't seen that, they're hysterical. They seem to have more planes than I've ever seen. So, back to work. I gotta put it together. And this will be in the air before you know it. I flew this last couple of weeks ago. I give this when we were allowed out. I took this out and give it a little fly around and flew great. I've lowered the kV of the motors, so these are 1700 kV motors, so this is 6S compatible. But I've got, I thought it was a little bit over propped, so I've actually got some 7-inch props. These are 6-inch props, 7-inch props that I could run on there. I'm gonna give it a try, but because I'm a naughty boy, I've ordered a new 7-inch frame, so I'm kind of looking forward to getting that. So that should be here any day now. I got stuff for my 3D printer. My cheap controller that was on there was only £3 odd. The display has lost a segment of the display, so I bought this display. So as you can see, so this is going to replace it, but I'm actually going to mount this into my enclosure. So, you know, I splashed out, this was about £4. Big bucks. Oh shit. And to run it all, I got this little lovely, absolutely beautiful power supply. It's a little 12-volt power supply, and that's going to run the cooling system, fans and everything. But I thought I'm going to get a dedicated power supply. I'm going to make the enclosure, so I plug the enclosure on, I switch the enclosure. It's going to be it's going to have its own power supply. I'm going to keep it separate off the 3D printer, but it's not going to put any strain on the 3D printer power supply. So these things are so cheap. Electronic controls, especially from Banggood, so cheap. I will share the 3D printed parts on Thingiverse, so I haven't done it yet. I'm going to upload it. I have got an account, so I'm going to put them on there. So if somebody wants to download them and have they might have a 20mm carbon boom and a bit of 15mm, but obviously it's dedicated to this plane. I'm going to put them there for safekeeping. But if somebody wants to take the parts, then so be it. If I can share the workable files, I'll do that as well. Thank you for watching Team Woolly Sheep Reviews, and I'll get back to you soon. So have a safe January. Bye.